who would like to be able to go from, well, actually, I don't think anyone would like to go to DC these days, but if you could go from Boston to DC in, say, 40 minutes, would you go there more often? Would it change the way you think about it? Yeah, probably. San Francisco to LA in 35 minutes, right? Awesome. For like 20 bucks, 30 bucks, totally different experience, right? Now, what if you were traveling at 750 miles an hour in a steel tube? Would you still be interested in doing it? Yes? Wow. We definitely have the right crew here. I was imagining people would be like, no way, that's crazy, you know. But obviously these are the early adopters and, you know, the risk takers, and probably 10% of you are gonna, you know, die prematurely of something, you know, some ill-fated choice. But you know, I was thinking that most people wouldn't be interested in doing that, and you know, you have to kind of suspend the disbelief. Is that really possible? Can we actually do that? 750 miles an hour shooting down a tube in a pod with 20 other people just sounds nuts. You're sitting behind basically the equivalent of a jet engine. But then I think, wait, a jet? What's a jet? You're flying in an aluminum tube at 500 miles an hour, 30,000 feet over the ocean, you know, with sitting on tons of fuel, right? We can suspend our disbelief and we can make things happen even if it seems impossible. So that's what the Hyperloop is. How many of you have heard of the Hyperloop? All right, good. Well, I really hadn't before I started working at Carnegie Mellon. And over the last 9 months, I've been working at the Integrated Innovation Institute. And while I was there, I became very familiar with it because I was invited to be an advisor on the team. Now, this is what the Hyperloop is. And recently, it's come to the fore because of this guy, Elon Musk. You all know him because he started Tesla and SpaceX and a number of other ventures that were very successful. And he wrote in 2013 a white paper with this idea about the Hyperloop. Now, the interesting thing is that we all think of him as kind of this brilliant thinker ahead of everyone else. But the fact is that the Hyperloop has been around for a very long time. The concept of the Hyperloop has been around for a very, very long time. Actually, even before 1870. Now, what I like about this slide is that you can see that guy in the tunnel. That is the conductor of the first Hyperloop. And he's standing on the outside, and it's going through the tunnel, and it's only a block long. So I think it might have been called a Hypo-loop rather than a Hyperloop, and I really can't understand the idea that was behind it. Like, they couldn't walk a block, and this thing is moving really, really slow. But the idea was there, and the idea was that it was pressurized and that it was being moved by air pressure. So cut to, here we are in 2013, Elon Musk writes this white paper. And he says, this is a great idea. It's going to be the 5th mode of transportation. We have boats, we have planes, we have cars, and what's the other? Trains. Yeah, we have trains. But they're inefficient. Each one has their efficiencies and inefficiencies. This is the 5th mode of transportation. But I'm not going to develop it. I want you all to develop it. I'm going to open this up. We'll support it with SpaceX knowledge and maybe a little bit of funding, but we're really not going to do anything. We're going to open it up to you. And so right away, 2 companies popped up, and they started working on this. They've invested tens of millions of dollars, right? And there are people working full time on this, and like really, really big facilities, building stuff, the highest tech of highest tech. In addition to which, there was a competition that was started right after this came out. And it started to be organized by Texas A&M. And initially, there were 700 applications from universities all around the world. 700 applications. No one's getting any money for this. These are like some of the smartest kids in the world that just said, this is really cool. I'm going to do this. I'm going to get involved with this. And Some of those people were at Carnegie Mellon. In fact, the school had 50 students that participated from the School of Design, from engineering, from business, from all different disciplines. And they worked through their vacations. They raised over $100,000, and this is just one school. And they need to because I'll explain later why they needed to raise so much money. But they're just doing this out of their own pockets, basically. And this is our team. And so I wanted to show you, at this event, it kind of went down from 700, and at the event, there were over 120 teams. This happened at the end of January 2016. 120 teams, about 1,200 students came, more were involved, and it was all to propose the best design for a pod for the Hyperloop. And it was like, I don't know, it was like a science fair on crack. It was just the most incredible event, and everyone was so excited and doing such interesting things. And the way, I like this one. Those red things in the back are a way of slowing down. They're balloons that inflate, and you're traveling through at 750 miles an hour in a tube, and they're emergency brakes. So it pops open, and the drag will fill up in the tunnel, and it'll stop the pod from moving forward. I mean, look at the detail that these kids came up with. It's phenomenal. So one of the things that a Hyperloop does, it's like, who's played air hockey before, right? You remember that game is there'd be lots of holes in the table, and the puck would float on there. Well, that's one of the key components and characteristics of a Hyperloop. So I'm just going to take you through a little bit of the science. Now, I'm not an engineer, I'm an industrial designer, but I became familiar enough to communicate with you. So one of the things is that it has to float on air, because any kind of wheel-based mechanism is going to create too much drag. So right away, once you get it off the ground, that's why planes can move so quickly. There are two ways to do that. One is maglev, using magnets, and that's kind of the way that you use in a high-speed train that they've been using, particularly in Japan, for many, many years. And the other is something called air bearings, which is more like the air hockey table. But instead of the table pushing the air out, it's actually skis that are inverted onto the track. Now, another characteristic is a tube. Now, the thing about this tube, I mean, this looks lovely. You're going through this tube at super fast speeds, and you're checking out the views and everything like that. But that's not actually what it looks like. You're actually going to be traveling in a steel tube that looks like that. But you'll see like all the renderings make it look like, wow, it looks so great. And the view from inside the tube looks something more like this. So now, one of the things about traveling this tube is that the tube has to be pressurized. And so there's a pressure differential behind the pod and what's in front of the pod. So if you imagine that you're in this tube and you're pushing this pod through, if there's nowhere for that air to go that's in front, it's going to work like a syringe, and the pressure is going to build up, and it's not going to be able to move forward. So they have to remove the pressure to the equivalent of basically flying at 30,000 feet in the air in the front of the pod. And then behind, it doesn't matter what the pressure is, but you have to get the air from in front out the back. So how do you do that? You do it with this. You do it with a compressor. That's a lot like a jet engine. It's a turbine, but as you can see here, that air has to go somewhere. So they filter it down through, and sometimes part of the air will be used for the air bearings, and part of it will be used for propulsion, extra propulsion, and part of it may be used for steering. So I just wanted to show you some of the other designs that have come up. They look pretty cool. They all look different. Now, the irony is that's the front. You think like that's going to be out the back and it's going to be shooting out, but it's actually exactly the opposite. It's not only for people. The first Hyperloop may be used for transporting goods. So imagine that you can get stuff back and forth every 30 minutes between San Francisco and LA, between Prague and Vienna, between London and Paris. Yes, you can build a tunnel underwater. It's been done. And this is someone's rendering of what it would look like inside the cabin. Now, each one is only about 65 feet long. It can hold between 20 and 30 people. And here's some of the other characteristics. I wanted to share this with you for a couple of reasons. One, because it's just something that's very interesting and very cool. And the other is because we're talking about moonshots today. And this would be a moonshot for transportation. But think about all of the energy and the effort and the resources that went into this, to transportation, this concept, how people willingly put in thousands and millions of hours into this and all the money. Now, what would happen if we did this for other things? How do we get people to do it for other things? And this is the captain of our team here. This is the moment that Elon Musk walked out on stage. They're like, he's not going to be here. He's not going to show up. And then he walks out and they're like, oh my God, it's Ringo Starr, or or maybe not Ringo, but. In any case, the point is that people were inspired. And not only were they inspired, but they knew how to do it. "750 miles an hour, shooting down a tube in a pod with 20 other people." Just sounds nuts. You're sitting behind basically the equivalent of a jet engine. But then I think, wait, a jet? What's a jet? You're flying in an aluminum tube at 500 miles an hour, 30,000 feet over the ocean, with sitting on, would it change the way you think about it? Yeah, probably. San Francisco to LA in 35 minutes, right? Awesome. For like 20 bucks, 30 bucks, totally different experience, right? Now, what if you were traveling at 750 miles an hour, and the risk takers, and probably 10% of you are going to die prematurely of something, some ill-fated choice. But I was thinking that most people wouldn't be interested in doing that, and you have to kind of suspend the disbelief. Is that really possible? Can we actually do that? Or in a steel tube, would you still be interested in doing it? Yes? Wow. We definitely have the right crew here. I was imagining people would be like, no way, that's crazy, but obviously these are the early adopters. Who would like to be able to go from, well, actually, I don't think anyone would like to go to DC these days, but if you could go from Boston to DC in, say, 40 minutes, would you go there more often?